Okay, we're on to common logarithms today. A common logarithm means the base is always 10. So for example, in this first one, we have log 10. When there's nothing written there, we always understand the base to be 10. And remember, when we're dissecting a logarithm, this is the base. Log means exponent, and then this is the answer. So for this case, it was saying 10 raised to what power gets you 10? That one's pretty easy to answer. It's 1. However, it gets a little hairy when we have example 2. Remember, it's a common log, which means base 10. And obviously it's base 10 because we have 10 fingers. So if I were to rewrite this, 10 to some exponent gets me 64. Well, we know 10 to the first gets me 10, and we know 10 squared gets me 100. So since 64 is between 10 and 100, our exponent has to be between 1 and 2. But the joy of this is that we have a calculator that will do this for us. So on our calculator, right here, we have a log key. And look, all we have to do, log 64. And there's our answer. And if we check it, 10 to this exponent, instead of typing the whole thing, we'll do the answer, it gets me 64. So, our answer for problem 2, x is approximately 1 point, and then we'll round to whatever the problem tells us to round to. So yeah, this homework can all be done on the calculator. This one's a little different. Here, they give us the exponent. We know the base is 10, and they're asking us to find the power or the answer. So 10 to 0.9876 gets me something. Well, there's two ways, once again, to do this on the calculator. We can do it the long way, which is type it in. 10 to the 0.9876. Or if you notice right here, on log, the inverse is 10 to the x. So if I press second function log, it already does the 10 and the caret for us. All we have to enter in is 0.9876. So we get our answer. And this you'll actually call anti-log. Anti means against. So we are unlogging, anti-logging. Instead of logging to find the exponent, we're giving the exponent, and we're going back to what the power is. So feel free to use whichever one. Likewise right here, this is base 10. So this is saying 10 to the 3.2345 will get me something. Now, I know my answer is going to be in the thousands, because 10 to the third gets me 1,000. So this is 10 to the third and a little more. So when I do this, I'm going to do anti-log. I'm going to anti-log 10, 3.2345. I know my answer is going to be in the thousands. And indeed it is. The answer is 1,715 point, and let's just round it to the nearest 10. Likewise right here. I'm anti-logging again. I'm taking 10 raising it to something, and I will get an answer. So inverse, whoops, didn't come up. Inverse log negative 1.3456. Can you figure out what that negative is going to do? Right, a negative tells you it's going to be a decimal. And indeed it is a decimal. And the decimal here is 0.045. So what you're trying to get straight today is when do you log and when do you anti-log? All right, we don't need the calculator anymore, so let's get rid of that. And this is how they will make logs hard for you. They know you can do it on the calculator, so in order to test you to see if you really know logarithms, they'll give you examples like this. So here's our clue. If every time we see the log of 5, we may replace it with the letter x. Every time I see the log of 7, we may replace it with a y. So I'm going to write each of these logs in terms of x and y. Log of 175. I don't know anything about the log of 175. All I know is about the log of 5 and the log of 7. So that means 5 and 7 are hidden in 175. All right, so if I look at this, 75 is 175 is 25 times 7. I'm getting there. And 25 is 5 times 5. So look, I found 5 and 7. Now if I keep rewriting this, we know there's no such thing as multiplication. So the log of 5 plus the log of 5 plus the log of 7. Hey, now I've got it. Every time I see the log of 5, I may replace it with an x. Hey, there's a log of 5. I'm going to replace it with an x. Hey, there's a log of 5. I'm going to replace it with an x. And the log of 7, they told me I could replace it with a y. So there. I rewrote this in terms of x and y. Okay, let's do the same thing. 5 and 7 are hidden in here. Well, that one's a little easier, because 5 times 7 gets you 35. And now if I have to rewrite this in terms of Napier's laws, I know it's the log of 5 times 7. Square root means 1/2 power. Powers are no longer powerful, so they fall down in front. And there's no such thing as multiplication. And since both the 7 and the 5 were getting square rooted, I had to put in parentheses. So this one is 1/2 the log of 5 plus the log of 7. And once again, it's still in parentheses, and there I have it. There's my log of 5. And I can replace my log of 5 with an x. And there's my log of 7. And I can replace log of 7 with a y. So there. I demonstrated I understood my log rules and how to rewrite them. This one's not that bad. Let's see if we can bounce through it really fast. Powers are no longer powerful, so they fall down in front. There is no such thing as division, so I will rewrite this as a subtraction problem. Awesome. Every time I see the log of 7, I may replace it with a y, and every time I see the log of 5, I may replace it with an x. There. I rewrote it in terms of x and y. Done.